Assalamu alaikum. This video for subtopic 5.1 focused questions. Let's start with the first question. The time taken by a pendulum to complete one oscillation is? The time taken to complete one cycle or one oscillation is period. Question number 2. The number of cycles that repetitions per second is the frequency. So the frequency with unit hertz, of course. So the unit of the frequency is hertz. The unit of the period is second. It's the time. Hertz is 1/second, by the way. It's the same. طيب. Now, Hooke's law is stated mathematically as F equal negative kx. What does the negative sign represent? Of course, this force is also called restoring force. So when the object goes to the right of the equilibrium, for example, the force will be to the left. When the object goes to the left of the equilibrium, the force always will be to the opposite direction. So the force is in the opposite direction of the displacement. Of course, this is right. The force is in the same direction of the displacement. Of course, that is not true. The force tries to restore the object to equilibrium. Yes, because it's always directed to the equilibrium. That's right. So 1 and 3. The answer is C. Next. The force versus extension data for spring are plotted on a graph as shown in the figure below. Now, part A. What is the spring constant? The spring constant is, the spring constant, from the formula we can say, okay, I'm sorry for that. Now, from the formula we can say F, let's write it here in the right place, better, right? F equal negative K over X. F over X equal K. Where is the negative? Actually, no need for the negative because the constant is always positive. The constant is always positive. Okay, now, K equal the slope. As you can see here, the slope is raise over run. The slope in math, slope is delta y over delta x. Here, y is the force, and x is the extension or the displacement. So the slope is the constant, and that's equal to change in force over change in extension or x. Now, we can choose any 2 points. Let's choose 0 and 12, for example. So it will be 12 minus 0 over 0.6 minus 0. So the answer is 20 Newton per meter. Okay, now part B. What is the spring potential energy when when it is stretched to length 0.5 meter. Actually, for this graph, also we can say the potential energy is the area under the graph. So potential energy of the spring equal area under the graph. Now it's very important to note that it is asking to the length of 0.5 meter. So we need to find the potential energy to this length only. So we will not calculate all the area. We will go only till 0.5, which is this one. So this is the area that we need to find. Clear? So this area, of course, it's triangle. Since it's a triangle, the potential energy SP equal 1/2 base times height. That means 1/2, 0.5 multiplied by 10, because the force here is 10. The answer is potential energy spring equal to 2.5 joules. Of course, any energy has this, all the energies has the same unit, which is joules. Next, what is the length of a pendulum that has period of 0.489? Okay, first we need to look at the formula sheet. Let's go to the formula sheet, and because I want you to check. Look at here. Okay. Yes, it is here. Now, how to decide which formula should I use? I mean, we have two formulas for the period. We have this one. We have also this one. Okay, so which one should I use? Actually, this one has K, so it's for the spring. This one has L, so it's the length of the string. So this one is for the pendulum. And of course, it's written here TP, T for the pendulum. Okay, so TP equal 2 by L over G, radical L over G. So here, okay, T equal 2 by radical L over G. T equal, actually we know T is 4.89, that's equal 2 by radical L over 9.8. Using the calculator, we can find that the answer is almost 5.94 meter. This is the length. Next question. Pendulum of mass M and length L oscillates between the labeled positions A, B, and C. Now, with period T. If the mass increased to 4m, what will happen to the period? Let's look at the formula. 2 by radical L over G. It has no relation with the mass. So the period will stay T. It will not be changed. since the formula is not related to the mass. The period is not related to the mass. Okay? Does the period of the pendulum, next question, does the period of the pendulum depends on, let's look, depends on the mass? No, it's not. Depends on the length of the string. Yes, this is the length of the string, so yes. The amplitude of the oscillation. No. Actually, no. As long as it is small angle. Yeah, let's say okay, below 15. Should be below 15 degrees. Other than that, it will be not simple harmonic motion. In this situation, we will have different story. It's not included in our curriculum. Now, what else does the period depends on? Actually, the gravity, G, as you can see here. So if we have different planet, it will be different period. So G, here gravitational field. Okay. And that's it for 5.1.